Ransomware and DDoS attacks happen all the time. Sometimes they affect large swaths of users. WannaCry ransomware froze the computer systems in hospitals in the UK. The Mirai botnet DDoS attacks took down a DNS provider, making Netflix and Twitter inaccessible for a short period of time. These are innocent attacks compared to what we could face from a world where cars and heart rate monitors and other safety-critical machinery become connected to the internet by default. This is not a new subject. We've covered it in previous episodes about security, but it's a deep subject, and there is much ground to cover. Chris Craig joins the show for this episode. He's a security researcher at Oak Ridge National Lab. He studies network and cloud security, and in this episode he brings his broad expertise to subjects like IoT security, car security, and the question of standards. What do we need to standardize and certify as the internet becomes connected to physical infrastructure? Thanks to Jared Smith for the introduction to Chris. The process of troubleshooting bugs can be tedious and inefficient for developers, especially as they push more and more code to production. The unlucky developer assigned to bug duty may get bombarded with error alerts and spend hours figuring out which errors to address first. They might have to deal with logs to piece together what happened, or even spend time reaching out to other engineers on their team for help. Bugsnag improves the task of troubleshooting errors by making it more enjoyable and less time-consuming. For example, when an error occurs, your team can get notified via Slack, see the diagnostic information on the error, and identify the developer who committed the code. Bugsnag's integration with Jira and other collaboration tools makes it easy to assign and track bugs as they are fixed. We have a special offer for Software Engineering Daily listeners. Try all features free for 60 days at bugsnag.com/sedaily. Development teams can now iterate faster and improve software quality. To get started, go to www.bugsnag.com/sedaily. Get up and running in 3 minutes. Airbnb, Lyft, and Shopify all use Bugsnag to monitor application errors. Try all features free for 60 days at bugsnag.com/sedaily. Thank you, Bugsnag, for being a sponsor of Software Engineering Daily. It's much appreciated. Chris Craig is a security researcher at Oak Ridge National Lab. Chris, welcome to Software Engineering Daily.
Oh, thank you.
So I want to go through a variety of topics around security, and I'm sure they will wind together, but I know you have a lot of different areas that you are familiar with, so I'm hoping we can get to a variety of them. And I want to start with the topic of cars. Why is vehicle computer security an important topic today?
I think in light of Charlie Miller and Chris Valasek making the G-Pack very popular, I think everyone's concerned with their cars, especially in America. I just came back from the UK where it's a concern, but not, they have plenty of public transit, but I think everyone's really concerned for the safety of these vehicles now that hacking is becoming far more of a household term, right? Or at least computer security is becoming a concern for just the everyday consumer. So I think specifically vehicle security is new because people perceive their cars as this giant black box that just, you put your key in it, you put some gas in it, and it goes. But they're kind of unaware of a lot of the technology going on behind the scenes that's been steadily improving and kind of built upon a trust platform that is, I think the best way to say is dwindling, especially as people are beginning to test and kind of prod at various aspects of these kind of really nicely built embedded devices. And they're starting to poke at it and realize that these were built with trust in mind, and that's not entirely the current kind of world now. So,
give an overview of the computer systems in a typical car and some of the vulnerabilities that are just on the surface of those computer systems.
So I can only really speak. I think you had Craig Smith on, who is
Yeah.
the dude. He's the guy, and I respect him greatly. I think I spoke with him actually at a conference. But the I can only speak to kind of my personal experience, and I come from a penetration testing background, so I can only kind of poke at, or I can only see the things I poke at. So your car is actually fairly noisy, especially when it's going down the road. There are various aspects of it in play, such as your head unit, for example. It can have anything from a USB stick to a CD drive to Bluetooth. And all of these could be feasible attack vectors. In fact, I believe some cars even have their own built-in browsers. And if they actually do have their own, for surfing the web, so you can connect to a wireless hotspot via your, sit in front of a Starbucks, connect to the local Starbucks, and surf the web from your own car and the entertainment unit. But you could also visit a malicious website from your car, and I doubt your car is running an updated version of Firefox or Chrome or some other very robust browser. So these are all kind of more surface level attack, very common attack surfaces, at least to get started. If you really want to get nuanced, there is the OBD2 port, which has kind of reached infamy at this point, at least in the vehicle security realm, because everyone wants a remote attack, but the OBD2 port is surprisingly noisy, and it's a great way to get a lot of control in a car that isn't necessarily designed for it. And I guess I'm not entirely sure if your readers know where the OBD2 port is. You know where you go to typically get your vehicle serviced, or if there's a check engine light, and there's that little kind of socket that's right underneath your steering wheel. Yeah, you can just plug into that, and it's screaming information all the time, and people can either use that to inject lights or certain messages, or they can use that to just read certain messages to kind of get a diagnostic of what your car is doing. There's other things like the tire pressure, TPM stuff as well is also another possible attack vector, but those attacks are those attacks are a little advanced.
Well, explain some of the nightmare attack vectors. Like, what are the, and how they, in terms of how they would manifest? I know that some of these were illustrated in that Wired article, and the video that went along with it. It was quite famous. But maybe you could just describe some of these for people who are unfamiliar, or if there have been some new attack vectors around the idea of a connected car that have arose since this kind of made its way into the mainstream.
Okay. So as far as kind of the nightmare scenario is, you press your brakes and they don't work, or you turn your steering wheel and it doesn't comply. Those things are, and I want to be careful here because Jeep has made a lot of changes since that video. And you can take one brief look at the stock price around 2005 and you could see all of the new innovations that they've came out with since. So these attack vectors are not as common, or at least the idea of a remotely connected car is starting to be something that's kind of dialed back. But that doesn't mean that your car isn't as finely or isn't as well connected internally. So, or that it doesn't want to call out. So two things that I kind of think of that come to mind are one nightmare scenario is one thing that we actually tried. You may be familiar with, I don't want to specifically name names, I'm not sure your brand thing, but there are certain insurance companies that are incentivizing safe driving programs, and they can use data mining on your OBD2 port, and they can basically read the CAN messages sent from your car. They can kind of profile your car in a particular way, and using the OBD2 port, because it's sending anything from the degree of your turn to how frequently you brake to when you turn on your lights during the time of day. All of that information can be derived and data mined from your CAN information from your OBD2 port. So they use that to drive safe driving. But if you could, which I think in one attack scenario we actually did try at our lab, you can kind of just fuzz messages, basically sending random garbage to the port. And we are fortunate enough to have a vehicle lab where we can test this aspect while driving. So we actually had the car up at like 40 miles an hour, and then we tried injecting, kind of putting in one of these fake sensors to inject just random CAN messages. And it was a hybrid car, and I think it told itself that the battery was off, and then it started to accelerate wildly
Oh my
and
God.
eventually it shut itself off. So, and that's not even a controlled attack. That's not even something that is, a very targeted payload. And I know Chris and Charlie made it look simple, but they actually spent 3 months reverse engineering reverse engineering aspects of the head unit to make sure that they can inject something from the head unit to the CAN bus. But if you can have direct control, you can just send garbage in and apparently get some interesting results. But as far as modern ones, the ones that make my ears perk up are instances like, where your car has a browser in it. It means that any website you visit has the potential, especially with things like Rowhammer, which is a modern kind of level attack that is a read-only attack, but you can read aspects of your memory and it can change bits. You can kind of pull that out to websites, and now websites can modify aspects of your computer. And so you have websites that can modify aspects of your car kind of remotely. And all this from just viewing a browser inside of your car. So
Why isn't the browser sandboxed properly?
I think it's because that's actually, so you bring about a very good question, which is, I thought all this was sandbox. Why is my head unit, talking to my car? Why does my head unit know about my brakes? Why are these two directly communicating to one another? Why aren't they walled off? And I think, I can't speak for vehicle manufacturers, of course, but I can tell you what I've seen. And that is that it does not appear to have been a thought. I think engineers from a lot of vehicle manufacturers just wanted to inform you. And the fastest, they wanted to inform you that you're going this speed, that your tire pressure is at this much, and that, if you want your Bluetooth connected phone to immediately connect to the first phone it sees or the first phone it remembers that looks similarly, these are all features, and they want to provide features in better cars for consumers. And a lot of the times these things are invented without, security in mind, or without proper kind of authorization and stuff like that. So that's why I think a lot of the times there really wasn't a wall present. And it's very difficult to update. I mean, Tesla's a great example of being able to just roll out features and update your car, but not everyone, not a lot of cars are built that way. And so, implementing something like that now is difficult, very difficult. And I think right now the solution is just buy a better car 5 to 10 years later. So
What's being done right now to standardize car security? Is anything being done?
I think I definitely see an effort towards, at the very least for new vehicles, there seem to be two pushes kind of in my mind. One is kind of walling off everything, separating the head unit from the rest of the CAN bus, making sure that the head unit can't see any of this stuff, which kind of walls off the highest attack vector, right? Like everyone uses your head unit, even the person in the passenger seat, uses your head, like in some way, right? They can fiddle with your radio. So there's been an increased effort as far as like walling that stuff off. But there's also policymakers that are trying to, well, that's more in the realm of safety. There are also certain policies that are kind of in place, like vehicle-to-vehicle communication and vehicle-to-infrastructure stuff that's being slowly rolled out, but I believe it's going to bear some fruit in the upcoming years, like probably 5 to 10 years, where your cars are talking to other cars and trying to kind of be safe along the road. But I think you're going to create another problem by solving a problem in that case.
I want to switch the topic to talking a bit about ransomware. We can come back to cars a little bit later. Ransomware is something that I was just not aware of as something that was going to be a big deal until it was a big deal. It is a big deal. What are your reflections on the series of mainstream ransomware attacks, these attacks that have made it into the public consciousness? What are your reflections on these that have taken place over the last several months?
I think the biggest one is WannaCry, right? Like that's the one that actually got everyone's attention. And the funniest thing about it, and I say funny from a place of dark humor. Many penetration testers have that kind of that kind of dark. They laugh at, they have that Schadenfreude. They laugh at the misery of the IT person or the programmer having to fix the bug. But what I think is kind of funny is one of the best solutions for it is to update your system. It's a great way, just keep your version of Windows up to date, and it actually has preventions in place to stop you from clicking, WannaCry.exe, which I jest because that's typically the injection vector, but its proliferation is actually the worm aspect of it is the scariest thing. I guess to answer your question directly, it feels like, and the reason I think the most important thing about it is the fact that it's not just grandma clicking a bad email attachment. WannaCry actually had a Windows vulnerability that was kind of like embedded in it, and it used it to worm its way across internal networks. So that means that it can not only jump between, it's not infecting one host, it's infecting, your subnet. And that, like, you're seeing, like, worms, which is kind of a type of attack that hasn't really been as popular outside of, like, email worms in the 90s and stuff like that. Like, it's kind of weird to see it again, but it also reminds you just how treacherous it is. And ransomware itself is bad because it's so cheap. It's not easy to implement, but it's really easy to modify and then throw right back out in the wild. And people are people, so you do what you can. But I think that at least the preventions for WannaCry is, just keep your stuff up to date, and it's very important to do so. And it's a hard problem for larger infrastructures, but you got to do it. You got to do it to survive and keep your infrastructure alive at this point.
I was watching WannaCry sort of closely when it came out. It was so, there's all these public pictures of people getting their electronic billboards shut down with ransomware or ATMs shut down with ransomware. All these pictures that were kind of hilarious but kind of terrifying and dystopian. But I my attention flagged a little bit when the Petya, there was Petya and then not Petya, these other things that I think were ransomware. I remember seeing these, at the top of Hacker News, and I didn't have time to read about them around them. But were these linked, or was this just sort of like a side effect of WannaCry being, an attack that really made its way into the mainstream, and then so everybody's eye was on ransomware, and then so coincidentally these other maybe less irregular attacks, ransomware attacks, just got more news because of that collateral from WannaCry. What exactly happened? What's with the Petya and the not Petya attacks?
I honestly don't know. This is sadly something I'm kind of weak on.
No
I
problem.
do know that a lot of these have mutated, right? Like, a mutation is a huge part of signature detection and trying to prevent further attacks down the road. But I'm not as familiar with Petya as I am like WannaCry and kind of the more mainstream ones.
Look for a job more efficiently with Indeed Prime. Indeed Prime flips the job search model and lets you find a job more efficiently even while you're busy with other engineering work or coding your side project. You simply upload your resume, and in one click, you get immediate exposure to companies like Facebook, Uber, and Dropbox. The employers that are interested will reach out to you within 1 week with salary, position, and equity up front. Don't let applying for jobs become a full-time job itself. With Indeed Prime, the jobs come to you. The average software developer gets 5 employer contacts and an average salary offer of $125,000 through Indeed Prime. It's 100% free for candidates. There are no strings attached. Sign up now at Indeed.com/SEDaily. Thank you to Indeed Prime for being a repeat sponsor of Software Engineering Daily. And if you want to support the show while looking for a new job, go to Indeed.com/SEDaily. So what about the subject of attribution? So trying to sort out where these attacks come from. A ransomware attack is a lot different than a directed cyber attack at a state actor. But in any case, the subject of attack attribution, this is something that's piqued my interest for a while, and we're about to do a series of shows about it because there was this big study that came out of the Rand Corporation, and I emailed a couple guys from there, so I think we're going to do some shows about that. But
Cool.
why don't you explain, from your discussions with people, maybe at Oak Ridge or at conferences, why is attribution so hard and why is it so important?
You got to know who attacked you at some point. And it's always a challenging subject because you can always geolocate some aspect of your IP, but it's a difficult question to answer directly in a very concise way. You want to know who's attacking you, but but everything was built by trust, right? And so in a way, everyone can lie. And and in an environment where you have, multiple networks and multiple connections and you have to stay busy, it's very difficult to find the needle in the haystack. And people's answers so far have been, all right, we'll just collect everything and then we'll suss it out later. Or we're going to get hacked anyway. So, let's just be on feature creep, keep releasing new stuff until eventually we get hacked, and then we'll come out with a public apology, and then we'll get our act together. Some businesses are taking advantage of that and trying to, provide insurance and response policies for in case when you get hacked, this is how you should reply, this is how you should respond, and it's a very difficult subject. At Oak Ridge, we're kind of concerned, of course, with government facilities and things of that nature, and recently we're more focused on the energy grid, being a member of the DOE, kind of protecting that and coming up with new technologies and new ways to kind of mitigate attacks that are coming in, of course, before they happen, and analyzing stuff if it does unfortunately happen, finding out the best way to attribute and then rectify any sort of attack. And a lot of that's been dependent on machine learning and taking advantage of Titan, because we have a supercomputer and we tend to use it. so we do take advantage of the resources available, but a lot of that's been recently taking advantage of machine learning and trying to classify these things to make at least the attribute problem a little bit easier. But it's still a bear. It's very hard to do.
How would machine learning be useful here? Do you have a labeled data set of traffic, and you can just kind of build correlations from those traffic patterns, and then when a new request comes in, you can know from machine learning that where it's coming from?
Yeah, it's kind of like signature detection in a way where I've seen this type of binary before. I'm just going to go ahead and clean it up before you.
Sorry, I don't know that term. What's that term? Signature detection?
Oh, pardon. I guess antiviruses in the past relied upon signature-based detection. So let's say, I keep bringing up grandma, and I don't mean to poke at grandmothers everywhere that are really keen on cybersecurity. But if, someone you love clicked a bad link or goes to a bad website and downloads something they shouldn't, standard or kind of older antiviruses at this point, it's still used, but they would recognize the binary that they downloaded, right, before they were able to double click it or anything of that nature, or open it or release it into the, actually execute the program downloaded. It would recognize it by its signature, right? They would have seen it before, put it in a database, and then your antivirus would recognize that same signature and delete it before you could do damage to yourself. So that's kind of the premise behind it. What machine learning can do, and at least my exposure to it so far, has been for classification. It's really good at classifying, or at least how we're using it. It's really good at classifying types of network traffic. This has been done kind of widely, but we're aiming to use it for kind of novel network traffic and kind of network patterns unique to our environments, because government labs are not really, we are large, but our networks are different than a lot of maybe corporate networks are kind of built. We have to rely upon a lot of public services and a lot of other public facilities, such as other laboratories and other universities and other governments, right, and other countries. So we kind of have to operate a little differently. So we use our machine learning techniques to analyze the traffic we particularly see and the ones that we see in the wild. And hopefully we see a few attacks, we see a few, benign stuff, and we build a machine learning algorithm that can classify between the two and hopefully alert you, if it's seen some type of a network traffic it's seen before.
Right, and just to be clear, you have to see the reason you said hopefully we see some attacks is because you need to see some attacks in order to build a classifier of attacks.
Yeah, and there are ways, that's actually part of my effort is, you can have some people in there poking at a machine in the ways that they know how, right? Like, I can help train it, right? I can try to attack a system while I'm there or try to do some other stuff to help train the bot, but you're not going to be able to prevent, well, actually you could, prevent some types of novel attacks provided they have certain primitives that you could detect. For example, let's say I have a really bad piece of malware and I keep changing it every time it's been detected. So the actual binary, the actual executable keeps changing. But I keep sending you an email, that's consistent with, my payload delivery is consistent. I can't recognize that particular signature, but I can recognize the network traffic. It's always consistent before my particular unique payload comes in. So I could train, a machine learning algorithm can know, well, it doesn't need to know the payload to know that it's a type of network pattern that's indicative of malicious behavior.
So you mentioned that you're working on power grid security. Can you talk a little bit more about that? What is involved in securing a power grid?
Well, I think the best way to I'm very new to this as of like 2 weeks ago. So, but that's kind of been our most recent initiative. My education with it, I'm just a lowly pen tester. I don't claim to be any higher than anyone else really learning. And I really see myself as a student of all these technologies. And my perception of it is not necessarily protecting the power grid, but once you start seeing the power grid, I think you may have heard like this buzzword, the smart grid and all that jazz. The smart grid, when you really take a look at it, is a sensor network and it's huge. And when you start to look at it like a network, then, that's old news, right? Like we've been protecting networks since networks have been out. But the power grid specifically has unique problems to it, specifically between trying to load balance power across multiple grids. How do you best distribute power, and how do you best so you can prevent brownouts and things of that nature? How do you secure your sensors? Because you may have rebels or whatnot. I say rebels, but you may have malicious attackers that are hacking their own smart grid sensors to give themselves all the power and to try to brown out an area. Or you could have them try to, in spite of what your base station is saying, say your base station is like, well, you're not at work, you're at home. I've consistently seen that during the hours of 9 to 5 or 9 o'clock a.m. to 5 o'clock p.m., you're not home, so I don't need to be sending every ounce of power I have to keep you furnished, to keep your house fully supplied as if you were going to turn on every single appliance in your house. But you could have people that are just trying to get power for free or to try to abuse it to take advantage of those low power usage times. There's a lot of interesting problems that can occur.
You sent me an article that Bruce Schneier wrote called Ransomware and the Internet of Things. And we've talked...
Yeah, Bruce.
Bruce, for sure. He was on the show early on. We did, I think one of the first 20 or 30 shows we did was with Bruce. And he's great guest, a really interesting guy to talk to. And what he's so good at is synthesizing a lot of different ideas and being able to articulate kind of the gestalt of the learnings that are going on in the security industry at any given time.
Yeah.
He's kind of like a Brian Krebs.
Yeah.
Although Brian Krebs seems like he's almost more of an investigative journalist, and he's not afraid to like get himself in the middle of the action. But anyway, so ransomware and the Internet of Things. We've already talked about both of these, basically. I mean, the Internet of Things in regard to cars and the power grid, perhaps things that like we kind of need on the Internet, but in some ways we really are afraid to put them on the Internet. We don't want them on the Internet. And ransomware, we already touched on this. Why are these two topics related?
I think they're related because, well, you have a trusted environment, and I say trusted because you want to really trust the Internet of Things. Like, I think a lot of people they want to have a digital thermometer or a digital thermostat. They want to be able to change it from home. They want to be able to control their power in case of brownouts. They want to be able, or your power company to say, yeah, you need more power, during brownouts. Or there's definitely a push from both, there's a push from both the commercial side and, the public for a lot of these small devices and more fine-grained control and better efficiency amongst these things that we use the IoT for. I kind of catching myself using IoT. I personally am studying sensor networks, and it makes IoT is a giant catch-all for a lot of things. So I'll continue to use it for this example, but my brain's kind of compartmentalizing them into Amazon Echoes versus full stack weather sensor networks and stuff like that. But
Sure.
I'll stay on topic. But I think they're kind of interconnected, specifically to ransomware, is because it's the idea that something so cheap could kind of break down something that is built on things that are supposed to be kind of cheap, right? The whole aspect of the things part of the Internet of Things is that they're kind of disposable. They're just a single use or a single item, right? That is just this small thing that essentially contributes to a larger, system. And the idea that I could be crippled by, someone, like my sensor network, for example, my weather sensor network could be crippled by someone walking up to a tree, grabbing my sensor and then fiddling with it. And then it worms its way through my entire network because they took down one of my insignificant things, right? It's kind of interesting in that way, but I do see the parallels. I do see how this is kind of growing in that way.
Mm-hmm. Well, Bruce has been beating on this drum since, well, I guess not exactly the ransomware and IoT stuff, but what was the major attack that hit that DNS?
Mirai, the Mirai botnet. We have data sets on that. We're digging.
What are you digging for?
Well, it's interesting because a lot of the things can't really be patched. Everyone's like, well, just update your firmware and whatnot. But some of the actual endpoints, the things in the Internet of Things that was compromised, are like DVD players. And how do you upgrade the firmware in your DVD? You throw it out and you buy a new one. You don't for a webcam, you just buy a new webcam. You don't typically plug it into your USB drive or worse, those things are typically placed and then kind of forgotten. You don't really remember that there's a webcam watching your, for example, let's say you're a college and that there's actually some weird webcam on campus that was installed for whatever reason. You can't really facilitate all of those nuanced things. And then all of a sudden, it's taking part in this huge DNS hack and now you're responsible. It's very interesting. I guess I'll say that much. Yeah, it's really interesting.
So if I've got my webcam or my DVD player, I guess these things are not set up to take updates to an operating system over the air, basically.
Yeah, it's kind of an afterthought. At least if they did think of it, you just hope that it's convenient. You really hope that you don't have to sit up there and have to download their proprietary software to specifically speak over USB or, heaven forbid, some sort of converter to plug into their micro USB port and then have to reflash the firmware of your $10 Chinese webcam because you just wanted to watch your front door when you're away, right? You have all this work, and people don't want to be sysadmins. Sysadmins barely want to be sysadmins. So
they want to be DevOps.
They want to be DevOps. They want to go nut out, but
Grammatech Code Sonar helps development teams improve code quality with static analysis. It helps flag issues early in the development process, allowing developers to release better code faster. Code Sonar can easily be integrated into any development process. Code Sonar performs advanced static analysis of C, C++, Java, and even raw binary code. Code Sonar performs unique data flow and symbolic execution analysis to aggressively scan for problems in your code. Just like battleships use sonar to detect objects deep underwater, Engineers use code sonar to detect subtle problems deep within their code. Go to go.grammatech.com/sedaily to get your free 30-day trial exclusively for Software Engineering Daily listeners. Code Sonar analyzes your code, and it delivers a detailed report. The Code Sonar user interface provides all the information that you need to quickly understand the reports, follow cross-functional paths, understand cross-references, quickly navigate between files, and visualize large pieces of your code. Go to go.grammatech.com/sedaily to get your 30-day free trial and unleash the power of advanced static analysis. Thanks to Grammatech for being a sponsor of Software Engineering Daily. Just to clarify for people who don't know about this attack, the Mirai botnet attack was basically there was a large company in China that made cameras that went on all kinds of products on webcams and security cameras, and I don't know name your kind of camera, the kind of camera that sits in a stuffed animal if you have a stuffed animal that has a camera in it, and these were all vulnerable to. Basically, they had the same login, so you could log into them remotely using the same. They had a standard username and password, and Mirai botnet found that out and logged into all of them, and then launched DDoS attacks. And Schneier's point around that time, and in this article about ransomware and IoT, is that the current model of Microsoft and Apple and other big corporations being able to protect us will fail in the Internet of Things. And I think part of that is because these companies, the giant companies, are no longer the only ones who can mass produce hardware and put that hardware in consumer products and put it in important places. I mean, what are the other reasons that this new wave of Internet of Things is different and requires a different approach?
I think, one of the most interesting aspects of it, and I know I keep harping on this because I really think it's kind of the core problem. It's not necessarily that I think there's a lot of players at stake. I think having a lot of players at stake, I mean, you can say what you want about the free market, but having a lot of players and, kind of influencing the web and influencing the Internet of Things is kind of just how kind of companies battle that out. It's how new fields are kind of waged over, like computing in the early 90s to mid 90s, right? And in some cases still now with Google. And I don't think it's so much the players as it is the problem of a small embedded group that doesn't necessarily have, they're just the lowest bidder, or they're just the lowest provider, right? They're the cheapest product, somehow influencing a lot of other businesses and a lot of other companies. And their reputation isn't as widely known, and their updating platform isn't as robust. I think a lot of this comes down to the fact that, sure, I can have 10 little webcams at my house and set up my own personal reenactment of Big Brother with myself and my dog. But I think that the biggest problem with this is the fact that I have to update all these, and that's not necessarily done in a very good or secure way. Even if a provider were to actually do that automatically or in a way that is less intrusive or kind of provide a very user-friendly way of securing the home. And I know that there are some people looking for that, especially through software-defined networks. That's actually an avenue some people are investigating of, maybe you don't need to be a big bad sysadmin, but maybe your home router can do some of this for you. It can actually take some of the burden out of managing this stuff for you. Some people are investigating that. But I really think it's the updating issue. It always comes back to people want to release a patch. If you don't release the patch, then you're not going to buy the product anymore. But you're going to lose business. But if you actually do fix the problem, it needs to get out there, and it needs to get out there now. And the bigger corporations can do that, and they have established frameworks for it. And a lot of the little guys are just struggling.
What do you think of the idea, and this is something Bruce talks about a lot, the idea that we need government intervention in IoT standards?
This, I think, well, you could argue the same way government intervention in the internet, right? It birthed it in a lot of ways. It made it possible. It made people, it allowed people to lay down cable and pipe and do a lot of other cool stuff. But at the same time, then you have aspects of it that are trying to vie for control and, try to take some of these things away. I'm not as, in spite of my status as a government employee, I'm not as. I think there is a strive for standardization and regulation, especially during kind of the early kind of fettered stages of this development, right? And I know that there are some efforts in the EU for like safety guidelines. So you can't release an IoT or you can't deploy an IoT product in the EU.
That sounds like the EU.
Yeah, it does sound like the EU. You can't deploy it unless it follows a certain guidelines, and there are these certain ways of updating it, and then privacy things are all put in place, and you can't even deploy your little webcam, or it's illegal to unless it follows all these guidelines. So that's kind of an extreme in my view. But I do think that there is a craving right now, and there's definitely a demand for some standard, for some way to communicate to these little things and have them behave in a way. In a way, kind of, it's like the early internet. I do see I'd see the analogy for those two, like, or the similarity between the two very strongly. You had each independent college coming out with its own way of doing communication, and then they all kind of TCP/IP just kind of won, and then everyone started communicating over TCP/IP as the kind of bona fide transport layer between college to college. So, I feel like there's definitely people fighting for something right now, but I think that's kind of, I'm not a betting man, but I feel like that's coming.
So I am a betting man, and what I would bet on is I think actually Bruce is wrong. I think that the model of the giant corporations is going to save us, because I think the thing is, these giant corporations are going to be able to layer so much value into their IoT offerings, whatever that means. Like like Android, for example, has an Internet of Things platform that I know that they're pushing. I've been trying to do a show about this. I haven't wrangled somebody from the team quite yet, but Android, there's a reason Android won the smartphone market, every aspect of it, where Apple didn't, is because basically they said, look, we're going to take care of all the crap that you don't want to take care of, and you build your application on top of it, and it's like, that's a great deal. And maybe the Amazon platform will be, okay, you get a voice assistant on top of it. Well, I guess I think that is Android. I think the Amazon Echo runs a version of Android, if I remember. But so I think like that's the direction. I mean, I'm editorializing here basically, but I mean that makes sense to me. And like, by the way, like, if you're the company who whatever that stupid camera company was, the Mirai botnet company that had all the same default username and password, if you're that company, it's not like you want this kind of crap to happen. Like, you would love to opt in for, I'll use the Android Things platform instead of some random Linux distribution, because I'm going to get all these additional things from an Android platform. I don't know. That's my point of view. I don't really understand what I don't understand what Bruce expects to get out of the government trying to regulate this stuff.
I think it's just more of like a wrangling the kids sort of thing, but I think also I have my own personal opinions in it, which is that I think, the kids will play. You're going to have a lot of smaller companies trying to use the Internet of Things in an effective way to offer a unique product for their customers. And while I do think, if Android or even Amazon or someone crazy, someone with a lot of clout can offer a consistent, standardized way of doing this, that way they take care of all the IoT junk. But as long as you build, your web cameras with these particular specifications, you can deploy our software in there and we'll take care of the nonsense for you. I still think it's kind of pushing towards some sort of standard, whether or not that's proprietary or if it's open is up for the mad grab. But I think the companies are going to fight that out.
So you also referred me to this paper on this very topic, the standardization and certification of the Internet of Things. And this was a good article. I'll put it in the show notes. It was kind of an overview of like attempts and discussions of of like this very topic. And the authors, to motivate this discussion, the authors describe a coming collision between two worlds. And this is sort of like similar alarm bells to what Bruce Schneier was ringing, but they describe this collision between two worlds, this world of patched software like an operating system, like, your Mac OS X. It updates overnight and it just gets patched, and that's totally fine. But then there's this other world that's the stable world of safety critical machinery, like a heart rate monitor. I'm sure you probably see this kind of stuff in the power grid space as well.
Yeah.
Why are these two worlds colliding?
It's a very interesting question. Like, why are they colliding? Why are they at odds with each other in this way? I mean, I'm a little stumped by it, honestly. I feel like, and the reason it confuses me isn't necessarily that I don't see that there is contention, but that it hasn't kind of that a hybrid hasn't kind of been met, right? Like that you have certain critical infrastructures that are completely unspoken for, but then you build a bigger, better network of patched software and all this other jazz on top of it. I guess the little sysadmin and kind of the sysadmin inside of me wants to marry the two, right? Like they don't need to fight.
Yeah. So I agree with you. And like, I know you do some hobbyist stuff with drones, and I don't know how much you've looked into drones. I did a show with somebody from Airware, and he was talking about how they do operating system security in drones, when it's basically like, okay, yeah, security is really important here, like just as important in a car as in a car. And they have these, basically every drone has two operating systems in it. And so they don't, like, they have their cake and eat it too, because they have a safety critical operating system and then a mission critical operating system that's supposed to be very inflexible. It's supposed to be the safety critical stuff. And then they have a very well-defined communication protocol between that and a more open operating system that sits on, in the same drone, and that that one's able to take high-level flexible commands, and it can sort of interpret them and perhaps filter them through to the more mission-critical operating system. So I don't think that this is like something that's mutually exclusive, but if that is the model, if it's like the two operating system model, one mission critical and one like more open, if that's what's going to be installed in all operating systems or more devices, then I guess that could change things.
Because technically you've just built the Linux kernel. If you really wanted to get
right,
nuanced enough about it, like there is a protected aspect of it, and there's users, and you can see this model kind of exhibited elsewhere. So yeah, I think right now everyone is just, I think we are kind of awash with the possibilities of what this could do. And much like, I think the time for scrapping maybe has passed. Like there was a lot of people scrapping at the early internet. And I think, I take that back. I think it's still fairly young as a field. But there's a lot that has yet to be kind of discovered and found out or tested in this new world.
Yeah. So, I'd love to find out a little bit more about what you're working on right now. So you touched on sensor networks, you touched on the power grid. Can you just give a little bit more of an outline of the research that you're focused on?
Okay. So previously my research upon joining Oak Ridge was upon like specifically network level security. I had worked in my previous employment was at Cisco Systems, and so networking's kind of you just do it. You just end up learning it at a routing company, So I was poking away at network systems, and at this point, Oak Ridge is a weird place. It is a national lab, but because I'm kind of ranked as an engineer, I get kind of thrown on projects nilly-willy, whatever's kind of available. So I've been working on specifically the vehicle security aspect stuff, which is kind of what I spoke about at my B-Sides talk. Vehicle-to-vehicle security, when that protocol's rolled out, what are its impacts. My new kind of interesting thing, which led me to drones actually, which is software-defined radio. People think radio is kind of dead, but then you end up looking at you're all of the stuff that's wireless in your house, and then you'll suddenly realize that you are you are very wrong. So software-defined radios and poking at that stuff. There's
What in my
also
house uses radio? Like what in somebody's house?
well, you got to think about specifically. You have the 802, right? You have the what is it? The two amateur bands, right? Which I think is at 2.4 gigahertz and 5.8 gigahertz are kind of the amateur bands, and in that you actually have wireless traffic. Bluetooth also operates in that. You have, standard radio. If you're talking about if I just set up a radio going inside my house, what will I see? You'll see those two bands typically. You'll see FM, AM radio. If you have, it's free to listen, but some channels are protected. But it's free to listen, but it's you need that ham license before you start transmitting stuff. But there's actually a surprising amount going on in this in the software defined radio field. So I'm just getting my toes wet in it. But the thing that got me it got me into drones, and specifically drone racing, which is my current kind of hobby, because I was fiddling around and it uses both 2.4 and 5.8 in order, or is it 5.4? I need to figure that out, to kind of navigate in order for you to see through the goggles as you're flying and to transmit, give your inputs, send your transmitter and actually fly it around. And people were talking about how you could hack it and how you could take advantage of more drones that are based on cinematography. So they don't really have, they're not as, they're very robust. And so you can actually take advantage of aspects in that. And it got me into the racing field. But as far as right now, I'm still finishing my thesis and I'm trying to focus it on wireless sensor networks. So it's throwing a bunch of networks across maybe a desert or a rainforest, and they collect information or disseminate information and report back to a base station. How do those things interact? And specifically, how do you verify the software running on that thing? If it's compromised and then someone drops it back in the same place, is it in the correct location? Has it been moved? Has the firmware been altered? And you need to verify this from the base station while consuming as little power as possible, because power is a priority for these things. They can't run forever. And communication is very expensive because it's the most costly thing for those batteries. So you have to kind of think about all these weird problems.
That's a super interesting problem set. Is that relevant to Oak Ridge or to what you're working on? Because this is kind of a military sort of thing, or I guess due to weather reporting. Why is security of a sensor network that might be sitting strewn throughout a desert? Why is that important? Why is security there a big concern?
Oh, just simply, well, one, you don't want people mucking with it in general, but yeah, you kind of can easily see the word sensor be replaced with soldier, and that tends to have its own impacts with our neighbors at the DoD. But as far as the DOE specifically, I can see it mostly for just you literally take the wireless part out of it and then replace sensor with a smart sensor, and then it's directly applicable to the smart grid, and you can do a lot of the cool and interesting stuff with your previous research that immediately applies to that. And so it's because you're working with small embedded devices that can't really do anything but read power and take in inputs and then govern power from that. And so it ends up kind of working fairly well.
Very cool. All right. Well, I want to begin to wrap up. What else are you looking at? What else is interesting in the area of network and cloud security and or anything that you're seeing at Oak Ridge? Because I know there's a lot of interesting projects at Oak Ridge.
Oh, man. Some of the cool stuff at Oak I wish I could say, well, right now we have at least two kind of cool-ish projects that are mostly related with, our focus is mostly on machine learning. How can we teach ourselves to classify bad behavior? That's a huge problem. And, we're actively working on aspects of that. And once you gather all this data, let's say you're awash with data, which is a particular problem with government facilities because of auditing, right? Like you can get audited for anything, so you just collect everything, but you end up having more logs than are what's useful. So you have this treasure trove of data of how your system or how any of these public services have been used. How do you mine that efficiently? How do you do that? And in the realm of security specifically, is there apparent behavior in these patterns? Is it somewhere buried in here? And what's the best way to visually present that? Those are pretty much the directives of our two teams, one led by John Goodall and the other group I belong to, which is the the Systems Security Research Team. We recently had a name change. The Systems Security Research Team. And those are kind of the problems that we're trying to investigate.
Great. Well, that sounds like a good place to conclude. Chris, thanks for coming on Software Engineering Daily. It's been really enjoyable and wide-ranging conversation about security.
Yeah. Thank you so much. It's been a pleasure.
Agreed. Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!